short message service is a text messaging service component of phone, web, or mobile communication systems. It uses standardized communications protocols to allow fixed-line or mobile phone devices to exchange short text messages. SMS was the most widely used data application, with an estimated 3.5 billion active users, or about 80% of all mobile phone subscribers at the end of 2010. The term SMS is used for both the user activity and all types of short text messaging in many parts of the world. SMS is also employed in direct marketing, known as SMS marketing. SMS as used on modern handsets originated from radio telegraphy and radio memo pages using standardized phone protocols. These were defined in 1985 as part of the Global System for Mobile Communications series of standards as a means of sending messages of up to 160 characters to and from GSM mobile handsets. Though most SMS messages are mobile-to-mobile text messages, support for the service has expanded to include other mobile technologies, such as ANSI-CDMA networks and digital amps, as well as satellite and landline networks. History. Initial concept. Adding text messaging functionality to mobile devices began in the early 1980s. The first action plan of the CEPT Group GSM was approved in December 1982, requesting that the services and facilities offered in the public switched telephone networks and public data networks should be available in the mobile system. This plan included the exchange of text messages either directly between mobile stations, or transmitted via message handling systems widely in use at that time. The SMS concept was developed in the Franco-German GSM cooperation in 1984 by Friedhelm Hillebrand and Bernard Gilbert. The GSM is optimized for telephony, since this was identified as its main application. The key idea for SMS was to use this telephone-optimized system, and to transport messages on the signaling paths needed to control the telephone traffic during time periods when no signaling traffic existed. In this way, unused resources in the system could be used to transport messages at minimal cost. However, it was necessary to limit the length of the messages to 128 bytes so that the messages could fit into the existing signaling formats. Based on his personal observations and on analysis of the typical lengths of postcard and telex messages, Hillebrand argued that 160 characters was sufficient to express most messages succinctly. SMS could be implemented in every mobile station by updating its software. Hence, a large base of SMS-capable terminals and networks existed when people began to use SMS. A new network element required was a specialized short message service center, and enhancements were required to the radio capacity and network transport infrastructure to accommodate growing SMS traffic. Early development. The technical development of SMS was a multinational collaboration supporting the framework of standards bodies. Through these organizations the technology was made freely available to the whole world. The first proposal which initiated the development of SMS was made by a contribution of Germany and France into the GSM Group meeting in February 1985 in Oslo. This proposal was further elaborated in GSM subgroup WP1 services based on a contribution from Germany. There were also initial discussions in the subgroup WP3 network aspects chaired by Jan Oudstad. The result was approved by the main GSM group in a June 85 document which was distributed to industry. The input documents on SMS had been prepared by Friedhelm Hillebrand with contributions from Bernard Gilbert. The definition that Friedhelm Hillebrand and Bernard Gilbert brought into GSM called for the provision of a message transmission service of alphanumeric messages to mobile users with acknowledgement capabilities. The last three words transformed SMS into something much more useful than the prevailing messaging paging that some in GSM might have had in mind. SMS was considered in the main GSM group as a possible service for the new digital cellular system. In GSM document OE services and facilities to be provided in the GSM system, both mobile-originated and mobile-terminated short messages appear on the table of GSM teleservices. The discussions on the GSM services were concluded in the recommendation GSM 02.03 OETL services supported by a GSM PLMN Here a rudimentary description of the three services was given: short message mobile terminated / point-to-point, the ability of a network to transmit a short message to a mobile phone. The message can be sent by phone or by a software application. Short message mobile originated / point-to-point, the ability of a network to transmit a short message sent by a mobile phone. The message can be sent to a phone or to a software application. Short message cell broadcast. The material elaborated in GSM and its WP1 subgroup was handed over in spring 1987 to a new GSM body called IDEG, which had its kickoff in May 1987 under the chairmanship of Friedhelm Hillebrand. The technical standard known today was largely created by IDEG as the two recommendations GSM 03.40 and GSM 03.41. WP4 created a drafting group message handling, which was responsible for the specification of SMS. Finn of Telenor chaired the draft group through its first 3 years, in which the design of SMS was established. DGMH had 5 to 8 participants, and Finn mentions as major contributors Kevin Holly, Elijah Altonen, Didier Luzard and Alan Cox. The first action plan mentions for the first time the technical specification 03.40 OE technical realization of the short message service Euro. Responsible editor was Finn Trisby. The first and very rudimentary draft of the technical specification was completed in November 1987. However, drafts useful for the manufacturers followed at a later stage in the period. A comprehensive description of the work in this period is given in. The work on the draft specification continued in the following few years, where Kevin Holly of Cellnet played a leading role. Besides the completion of the main specification GSM 03.40, the detailed protocol specifications on the system interfaces also needed to be completed. Support in other architectures. The mobile application part of the SS7 protocol included support for the transport of short messages through the core network from its inception. MAP Phase 2 expanded support for SMS by introducing a separate operation code for mobile terminated short message transport. Since Phase 2, there have been no changes to the short message operation packages in MAP, although other operation packages have been enhanced to support Camel SMS control. From 3GPP releases 99 and 4 onwards, Camel Phase 3 introduced the ability for the intelligent network to control aspects of the mobile-originated short message service, while Camel Phase 4, as part of 3GPP Release 5 and onwards, provides the IN with the ability to control the mobile-terminated service. Camel allows the GSM-SCP to block the submission or delivery of short messages, route messages to destinations other than that specified by the user, and perform real-time billing for the use of the service. Prior to standardized Camel control of the short message service, IN-Control relied on switch vendor-specific extensions to the intelligent network application part of SS7. Early implementations. The first SMS message was sent over the Vodafone GSM network in the United Kingdom on December 3, 1992, from Neil Pupworth of Samer Group using a personal computer to Richard Jarvis of Vodafone using an Orbyte 901 handset. The text of the message was OE Merry Christmas The first commercial deployment of a short message service center was by Oldiscon, part of Logical with Telia in Sweden in 1993, followed by Fleet Call in the US, Telenor in Norway and BT Cellnet later in 1993. All first installations of SMS gateways were for network notifications sent to mobile phones, usually to inform of voicemail messages. The first commercially sold SMS service was offered to consumers, as a person-to-person text messaging service by Radilinja in Finland in 1993. Most early GSM mobile phone handsets did not support the ability to send SMS text messages, and Nokia was the only handset manufacturer whose total GSM phone line in 1993 supported user sending of SMS text messages. Initial growth was slow, with customers in 1995 sending on average only 0.4 messages per GSM customer per month. One factor in the slow take-up of SMS was that operators were slow to set up charging systems, especially for prepaid subscribers, and eliminate billing fraud, which was possible by changing SMSC settings on individual handsets to use the SMSCs of other operators. Initially, networks in the UK only allowed customers to send messages to other users on the same network, limiting the usefulness of the service. This restriction was lifted in 1999. Over time, this issue was eliminated by switch billing instead of billing at the SMSC and by new features within SMSCs to allow blocking of foreign mobile users sending messages through it. By the end of 2000, the average number of messages reached 35 per user per month, and on Christmas Day 2006, over 205 million messages were sent in the UK alone. It is also alleged that the fact that roaming customers, in the early days, rarely received bills for their SMSs after holidays abroad, which gave a boost to text messaging as an alternative to voice calls. Text messaging outside GSM, SMS was originally designed as part of GSM, but is now available on a wide range of networks, including 3G networks. However, not all text messaging systems use SMS, and some notable alternative implementations of the concept include J-Phone's SkyMail and NTT Docomo's ShortMail, both in Japan. Email messaging from phones, as popularized by NTT Docomo's iMode and the RIM BlackBerry, also typically uses standard mail protocols such as SMTP over TCP/IP. SMS today, in 2010, 6.1 trillion SMS text messages were sent. This translates into an average of 193,000 SMS per second. SMS has become a huge commercial industry, earning $114.6 billion globally in 2010. The global average price for an SMS message is 11 cents, while mobile networks charge each other interconnect fees of at least 4 cents when connecting between different phone networks. While SMS is still a growing market, traditional SMS is becoming increasingly challenged by alternative messaging services available on smartphones with data connections, especially in Western countries where these services are growing in popularity. Technical details: GSM. The short message service Point-to-Pointer was originally defined in GSM Recommendation 03.40, which is now maintained in 3GPP as TS 23.040. GSM 03.41 defines the short message service cell broadcast, which allows messages to be broadcast to all mobile users in a specified geographical area. Messages are sent to a short message service center, which provides a store-on-forward mechanism. It attempts to send messages to the SMSC's recipients. If a recipient is not reachable, the SMSC queues the message for later retry. Some SMSCs also provide a forward and forget option where transmission is tried only once. Both mobile terminated and mobile originating operations are supported. Message delivery is a best effort, so there are no guarantees that a message will actually be delivered to its recipient, but delay or complete loss of a message is uncommon, typically affecting less than 5% of messages. Some providers allow users to request delivery reports either via the SMS settings of most modern phones, or by prefixing each message with 0 or N. However, the exact meaning of confirmations varies from reaching the network, to being queued for sending, to being sent, to receiving a confirmation of receipt from the target device, and users are often not informed of the specific type of success being reported. SMS is a stateless communication protocol in which every SMS message is considered entirely independent of other messages. Enterprise applications using SMS as a data bearer require that session management be maintained external to the protocol. Message size: transmission of short messages between the SMSC and the handset is done whenever using the mobile application part of the SS7 protocol. Messages are sent with the MAPMO and MT4SM operations, whose payload length is limited by the constraints of the signaling protocol to precisely 140 octets. Short messages can be encoded using a variety of alphabets, the default GSM 7-bit alphabet, the 8-bit data alphabet, and the 16-bit UCS2 alphabet. Depending on which alphabet the subscriber has configured in the handset, this leads to the maximum individual short message sizes of 167-bit characters, 148-bit characters, or 7016-bit characters. GSM 7-bit alphabet support is mandatory for GSM handsets and network elements, but characters in languages such as Arabic, Chinese, Korean, Japanese, or Cyrillic alphabet languages must be encoded using the 16-bit UCS2 character encoding. Routing data and other metadata is additional to the payload size. Larger content can be sent using multiple messages, in which case each message will start with a user data header containing segmentation information. Since UDH is part of the payload, the number of available characters per segment is lower, 153 for 7-bit encoding, 134 for 8-bit encoding and 67 for 16-bit encoding. The receiving handset is then responsible for reassembling the message and presenting it to the user as one long message. While the standard theoretically permits up to 255 segments, 6 to 8 segment messages are the practical maximum, and long messages are often billed as equivalent to multiple SMS messages. Some providers have offered length-oriented pricing schemes for messages, however, the phenomenon is disappearing. Gateway providers. SMS gateway providers facilitate SMS traffic between businesses and mobile subscribers, including mission-critical messages, SMS for enterprises, content delivery, and entertainment services involving SMS, for example TV voting. Considering SMS messaging performance and cost, as well as the level of messaging services, SMS gateway providers can be classified as aggregators or SS7 providers. The aggregator model is based on multiple agreements with mobile carriers to exchange two-way SMS traffic into and out of the operator's SMSC, also known as local termination model. Aggregators lack direct access into the SS7 protocol, which is the protocol where the SMS messages are exchanged. SMS messages are delivered to the operator's SMSC, but not the subscriber's handset. The SMSC takes care of further handling of the message through the SS7 network. Another type of SMS gateway provider is based on SS7 connectivity to route SMS messages, also known as international termination model. The advantage of this model is the ability to route data directly through SS7, which gives the provider total control and visibility of the complete path during SMS routing. This means SMS messages can be sent directly to and from recipients without having to go through the SMSCs of other mobile operators. Therefore, it is possible to avoid delays and message losses, offering full delivery guarantees of messages and optimized routing. This model is particularly efficient when used in mission-critical messaging and SMS used in corporate communications. Interconnectivity with other networks. Message service centers communicate with the public land mobile network or PSTN via interworking and gateway MSCs. Subscriber-originated messages are transported from a handset to a service center, and may be destined for mobile users, subscribers on a fixed network, or value-added service providers, also known as application-terminated. Subscriber-terminated messages are transported from the service center to the destination handset, and may originate from mobile users, from fixed network subscribers, or from other sources such as VASPs. On some carriers, non-subscribers can send messages to a subscriber's phone using an email to SMS gateway. Additionally, many carriers, including AT&T Mobility, T-Mobile USA, Sprint, and Verizon Wireless, offer the ability to do this through their respective websites. For example, an AT&T subscriber whose phone number was 555-555-5555 would receive emails addressed to 5,555,555,555 at txt.net as text messages. Subscribers can easily reply to these SMS messages, and the SMS reply is sent back to the original email address. Sending email to SMS is free for the sender, but the recipient is subject to the standard delivery charges. Only the first 160 characters of an email message can be delivered to a phone, and only 160 characters can be sent from a phone. text-enabled fixed-line handsets are required to receive messages in text format. However, messages can be delivered to non-enabled phones using text-to-speech conversion. Short messages can send binary content such as ringtones or logos, as well as over-the-air programming or configuration data. Such uses are a vendor-specific extension of the GSM specification, and there are multiple competing standards, although Nokia's smart messaging is common. An alternative way for sending such binary content is Sms messaging, which is standardized and not dependent on vendors. SMS is used for M2M communication. For instance, there is an LED display machine controlled by SMS, and some vehicle tracking companies use SMS for their data transport or telemetry needs. SMS usage for these purposes is slowly being superseded by GPRS services owing to their lower overall cost. GPRS is offered by smaller telco players as a route of sending SMS text to reduce the cost of SMS texting internationally. AT commands. Many mobile and satellite transceiver units support the sending and receiving of SMS using an extended version of the Hayes command set, a specific command language originally developed for the Hayes Smart Modem 300 baud modem in 1977. The connection between the terminal equipment and the transceiver can be realized with a serial cable, a Bluetooth link, an infrared link, etc. Common AT commands include AT plus CMGS, AT plus CMSS, AT plus CMGL and AT plus CMGR. However, not all modern devices support receiving of messages if the message storage is not accessible using AT commands. Premium-rated short messages. Short messages may be used normally to provide premium-rate services to subscribers of a telephone network. Mobile terminated short messages can be used to deliver digital content such as news alerts, financial information, logos, and ringtones. The first premium-rate media content delivered via the SMS system was the world's first paid downloadable ringing tones, as commercially launched by Sonalati, and much more. Premium-rated messages are also used in donors' message service to collect money for charities and foundations. DMS was first launched at April 1, 2004, and is very popular in the Czech Republic. For example, the Czech people sent over 1.5 million messages to help South Asia recover from the 2004 Indian Ocean earthquake. The value-added service provider providing the content submits the message to the mobile operator's SMS CS, using an TCP/IP protocol such as the short message peer-to-peer protocol or the external machine interface. The SMSC delivers the text using the normal mobile terminated delivery procedure. The subscribers are charged extra for receiving this premium content. The revenue is typically divided between the mobile network operator and the VASP either through revenue share or a fixed transport fee. Submission to the SMSC is usually handled by a third party. Mobile-originated short messages may also be used in a premium-rated manner for services such as televoting. In this case, the VASP providing the service obtains a short code from the telephone network operator, and subscribers send texts to that number. The payouts to the carriers vary by carrier. Percentages paid are greatest on the lowest-priced premium SMS services. Most information providers should expect to pay about 45% of the cost of the premium SMS upfront to the carrier. The submission of the text to the SMSC is identical to a standard MO short message submission, but once the text is at the SMSC, the service center identifies the short code as a premium service. The SC will then direct the content of the text message to the VASP, typically using an IP protocol such as SMPP or ME. Subscribers are charged a premium for the sending of such messages, with the revenue typically shared between the network operator and the VASP. Short codes only work within one country, they are not international. An alternative to inbound SMS is based on long numbers, which can be used in place of short codes for SMS reception in several applications, such as TV voting, product promotions and campaigns. Long numbers work internationally, allow businesses to use their own numbers, rather than short codes, which are usually shared across many brands. Additionally, long numbers are non-premium inbound numbers. Threaded SMS. Threaded SMS is a visual styling orientation of SMS message history that arranges messages to and from a contact in chronological order on a single screen. Visually, this style of representation provides a back-and-forth chat-like history for each individual contact. Hierarchical threading at the conversation level is not widely supported by SMS messaging clients. This limitation is due to the fact that there is no session identifier or subject line passed back and forth between sent and received messages in the header data from which the client device can properly thread an incoming message to a specific dialogue, or even to a specific message within a dialogue. Most smartphone text messaging clients are able to create some contextual threading of group messages, which narrows the context of the thread around the common interests shared by group members. On the other hand, advanced enterprise messaging applications which push messages from a remote server often display a dynamically changing reply number, which is used along with the sender's phone number to create session tracking capabilities analogous to the functionality that cookies provide for web browsing. As one pervasive example, this technique is used to extend the functionality of many instant messenger applications such that they are able to communicate over two-way dialogues with a much larger SMS user base. In cases where multiple reply numbers are used by the enterprise server to maintain the dialogue, the visual conversation threading on the client may be separated into multiple threads. Application to Person SMS. While SMS reached its popularity as a person-to-person messaging, another type of SMS is growing fast: application-to-person messaging. A2P is a type of SMS sent from a subscriber to an application or sent from an application to a subscriber. It is commonly used by financial institutions, airlines, hotel booking sites, social networks, and other organizations sending SMS from their systems to their customers. According to research in 2011, A2P traffic is growing faster than P2P messaging traffic. Satellite phone networks. All commercial satellite phone networks except ACES and Optus support SMS. While early Iridium handsets only support incoming SMS, later models can also send messages. The price per message varies for different networks. Unlike some mobile phone networks, there is no extra charge for sending international SMS or to send one to a different satellite phone network. SMS can sometimes be sent from areas where the signal is too poor to make a voice call. Satellite phone networks usually have web-based or email-based SMS portals where one can send free SMS to phones on that particular network. Unreliability. Unlike dedicated texting systems like the Simple Network Paging Protocol and Motorola's Reflex Protocol, SMS message delivery is not guaranteed, and many implementations provide no mechanism through which a sender can determine whether an SMS message has been delivered in a timely manner. SMS messages are generally treated as lower priority traffic than voice, and various studies have shown that around 1% to 5% of messages are lost entirely, even during normal operation conditions, and others may not be delivered until long after their relevance has passed. The use of SMS as an emergency notification service in particular has been starkly criticized. Vulnerabilities. The global service for mobile communications, with the greatest worldwide number of users, succumbs to several security vulnerabilities. In the GSM, only the airway traffic between the mobile station and the base transceiver station is optionally encrypted with a weak and broken stream cipher. The authentication is unilateral and also vulnerable. There are also many other security vulnerabilities and shortcomings. Such vulnerabilities are inherent to SMS as one of the superior and well-tried services with a global availability in the GSM networks. SMS messaging has some extra security vulnerabilities due to its store and forward feature, and the problem of fake SMS that can be conducted via the Internet. When a user is roaming, SMS content passes through different networks, perhaps including the Internet, and is exposed to various vulnerabilities and attacks. Another concern arises when an adversary gets access to a phone and reads the previous unprotected messages. In October 2005, researchers from Pennsylvania State University published an analysis of vulnerabilities in SMS-capable cellular networks. The researchers speculated that attackers might exploit the open functionality of these networks to disrupt them or cause them to fail, possibly on a nationwide scale. SMS spoofing. The GSM industry has identified a number of potential fraud attacks on mobile operators that can be delivered via abuse of SMS messaging services. The most serious threat is SMS spoofing, which occurs when a fraudster manipulates address information in order to impersonate a user that has roamed onto a foreign network and is submitting messages to the home network. Frequently, these messages are addressed to destinations outside the home network, with the home SMSC essentially being a hijacket to send messages into other networks. The only sure way of detecting and blocking spoofed messages is to screen incoming mobile-originated messages to verify that the sender is a valid subscriber and that the message is coming from a valid and correct location. This can be implemented by adding an intelligent routing function to the network that can query originating subscriber details from the HLR before the message is submitted for delivery. This kind of intelligent routing function is beyond the capabilities of legacy messaging infrastructure. Limitation. In an effort to limit telemarketers who had taken to bombarding users with hordes of unsolicited messages, India introduced new regulations in September 2011, including a cap of 3,000 SMS messages per subscriber per month, or an average of 100 per subscriber per day. Due to representations received from some of the service providers and consumers, TRAI has raised this limit to 200 SMS messages per SIM per day in case of prepaid services, and up to 6,000 SMS messages per SIM per month in case of postpaid services, with effect from November 1, 2011. However, it was ruled unconstitutional by the Delhi High Court, but there are some limitations. Flash SMS. A flash SMS is a type of SMS that appears directly on the main screen without user interaction and is not automatically stored in the inbox. It can be useful in emergencies, such as a fire alarm or cases of confidentiality, as in delivering one-time passwords. Silent SMS, silent messages, also known as a ESLint TMS, a stealth SMS, or a stealth ping, are employed nowadays to locate a person and thus to create a complete movement profile. They do not show up on a display, nor trigger any acoustical signal when received. Their primary purpose was to deliver special services of the network operator to any cell phone. The mobile provider, often at the behest of the police, will capture data such as subscriber identification (IMSI). In Germany in 2010, almost 500,000 silent SMS messages were sent by the Federal Police, Customs and the Secret Service for Verfassungsschutz. See also, Process-Driven Messaging Service, Comparison of Mobile Phone Standards, SMS Language, Telegram, Text Messaging, Thumbing, GSM 3.40, Short Message Service Center, Short Message Service Technical Realization, SMS Gateway, SMS Hubbing, SMS Home Routing, Multimedia Messaging Service, Extended Messaging Service, Enhanced Messaging Service, References. External links, 3GPP, the organization that maintains the SMS specification. ISO standards, GSM 3.38 to Unicode, the official GSM.